Students, we are into 3.3 homework here. And let's take a look here. So again, they ask you to illustrate this with different methods. You're going to be in the same boat doing different methods. Construct an addition table for base 8. Let's see here. Maybe I'll do a couple of these problems. One fact in a fact family is this. What are the other three? So we talked about that in the video for the class. You can also see it in the book. It's nothing too complicated. What conditions must be placed on A and B to make sure that A minus B can be performed within the set of whole numbers? That was also talked about. That's in the definition. Rewrite the following as an equivalent addition problem. Now it has a missing X. Again, that's because you're a college student. If you were doing this with some younger students in, say, grades single digit like that, maybe grades 1 through 2, maybe 3, but mostly grades first and second grade, you wouldn't put an X in here. You'd put a tree that is big enough that someone could write inside of it. And if you haven't seen those, it's the exact same concept. It's 9 minus 7 equals, and then they put like a tree like this, right? Right? And so you have to find how much is a tree worth as you do it. And so the idea is it's still holding the place of a number. And yeah, the number is 2, but in this case, remember, it just wants you to rewrite as an addition problem. What else do we have? Analyze the computations. Oh, yes, I guarantee you're going to see one of these on the test. So I said on the test, I'm not going to give you too much in base 10. I'll give you base 10, but I will give it to you from a student who is making a mistake. And I need you to be able to kind of say, what is wrong? What is the student missing as they do these, right? So if you look up here, this student is doing a great job of addition. 8 plus 5 is 13, right? So they wrote 13 down. 7 plus 2 is 9. Boom. So it's like, what are they doing right? And what might they not be doing fully correct? What could they do better, right? Let's see here. Equal additions problem. Wow. This is like, look at this, right? Tom's diet allows 1,500 calories per day for breakfast. Had skim milk, a waffle with no syrup, a dry waffle, and a banana. All right, I guess. For lunch, had a half cup of salad with mayonnaise. Okay. And then had pecan pie. There you go, Tom. Nicely done. For a lunch dessert, 570. It's like double the calories of the salad and mayonnaise, right? Well, it's probably true. Pecan pie is like just loaded with corn syrup. So half cup of salad with no mayonnaise. Can he have fish and tea? And tea has no calories. Again, so we're just kind of looking at additions. In real life, though, this isn't done quite as much. I think almost everybody nowadays is using some kind of app to track their food consumption. You can scan things. So it's kind of a throwback question. I agree. Let's see here. What do we have? Find the number to put in the blank to make each equation true. 3423 minus something gives us this number. Hey, if this is a missing subtrahend problem because you're missing part of subtraction, maybe think of rewriting this as an addition problem or a different subtraction problem, depending on what you're missing. Right? So again, picture this. If you're struggling with that type of question, picture this. What if it was base 10? Go back to your problem solving strategies from chapter 1. If it was base 10, maybe I have 317 minus I don't know what, but at the end of the day, they gave me back $85. So I had $317. I bought something and I got $85 in change back. Okay, but take a look. Think of that as X, right? Because it's a missing piece. That's all it is. If you want, think of it as a cloud. You want cloud? Fine, we'll do cloud. So then rewrite this where I'm adding cloud to both sides because that's equivalent. And all of a sudden, I get 85 plus cloud. I've turned the problem into a missing addend subtraction problem. And to get the cloud by itself, all I have to do is take away 85. So really, I've turned the problem back into something that's more than manageable. I now have that my cloud up here is equal to 317 minus 85. Totally up to me how I choose to do this problem. I see 7 minus 5 is 2, but I really like the 20 being added on because that turns this into 105 and makes this 337. And that gives me 232. And I'm done very quickly with that problem. Okay. Okay, what else do we have? So we have different number bases. That's fine. Base 5, base 12, doesn't matter. Just remember base 12, it says TEE. Remember, that is just 10 of these. This is 11, and this is 11 in that place value, right? So remember, your place values are 1s, then 12s, and then 12 squared, which is 144s. But if you are regrouping, this is the great part, right? If you are regrouping, then when you regroup, it looks like this. You take 10, you have 9 left, and you can bring over 1e. That's one group of 12 plus 11. So that'd be 23 of them down there. Oh, what else do we have? We have perform the operation. Ooh, hours, minutes, and seconds. Love these, right? Now your regrouping is not in tens. It's like a base problem. And in the number base problem, in this case, you'd be regrouping probably with 60s, right? Because 1 minute is worth 60 additional seconds. So you can trade that off and balance things out. Let's see here. Counting up, use the table blocks, use trades first. They just kind of go through a few. Question 15, place the digits in the boxes to obtain the greatest difference. So you want the biggest difference possible that you could possibly obtain. So again, think about that. How would I make things that are further apart, right? Clearly, if I have an 8 and a 2, I don't want to put the 8 up here and the 2 up here because that's a pretty big difference of around 600. If I put the 8 up front and the 7 below it, maybe that's less of a difference. But maybe there's other numbers that are off by 1, and I want to save the 8 because the bigger the number is down here that I'm subtracting, the closer it would be. Again, good questions to ask as you're doing a problem like this. And try a few, try a couple, see if you can get different differences as you look at those. Complete mentally. So those are all very similar. Let's see if you have any issues with what is 3.3. So 3.1, 5 to 8, 10 to 12. Okay, 1. Take things away with different approaches. That should be okay. 5 to 8. Boom, 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 boom. This says find the solution in the set W. So there must be a whole number that works for these. Rewrite each of the following as an equivalent addition problem. So that seems very similar. Which number sentence shows how many more pencils Ross has than Kirsten? Okay. And 8, analyze the wrong computations. So something happened here. What'd they do? Right? B is probably the most common one, even for, I'm not going to lie, college students. Right? They look at this and they're like, yeah, the difference between 5 and 3 is 2. The difference between 7 and 8 is 1. So boom, 21. All right. What's the issue? What's going well? What's not going well? And then fill in the missing digits to complete the subtraction problem. Those are kind of fun, I think. Here, this is gallons, pints, quarts. I love being in America because in America, you actually need to know these things. Everywhere else in the world, it would be like milliliters, right? Everywhere else in the world, they would not have this much trouble, as much trouble as we do. Again, same type of thing here. Find the base equations, perform the operations using the bases listed. You have a couple base 5, a base 2. This are base 6 problems, but again, very, very similar as you go. Right, let's do one of these in base 7 as example, right? Why don't I do a base 7 problem? It's kind of similar. All right, here we go. So let's do this problem, but we'll do it in base 7. So, ooh, let me get some white space. Maybe that'll be easier. Do it in the middle of the screen. Here we go. Boop, boop, doop, 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 doop. Okay, so I'm going to do 2, 3, 1, minus 1, 4, 4, but I'm going to do it in base 7. Okay, so we'll start on the right-hand side. Works for me. We'll do something more traditional. That's fine. We don't have to. Right? We could do any of the methods that we've seen here today. Let's see here. So, and why don't I'll show 2 different methods. You can kind of see which one we like best. This one's more traditional. So I'm going to take one group of 7. That leaves me with 2 groups of 7. I bring over one group of 7 here. That's 7 plus 1. That's 8. And 8 minus 4 is 4. Okay. And then down here, I have 2. 2 take away 4. Oops, I need a few extras. So I'm going to take one from here and regroup it. This is a 7 that I just wrote down. One group of 7. 7 plus 2 is 9. 9 minus 4 is 5. And I get 0. So my final answer would be 5, 4, base 7. Okay. Now, let's say you didn't want to do that technique. You want to try something else. You're like, hey, Scott, I'm trying a whole bunch of cool things. Let me know what I could do. So here you could add, remember your base is 7. So maybe I would add 3 to each of these numbers. So that would give me 2, 3, 4 on top. And underneath, when I add 3 to the 4, I get 7, which would be 0 and 1 more going up. Okay, and again, now I could add 2, 0 to both of these to again regroup. So this would turn into 2, 5, 4. And down here, 5 plus 2 would give me a 7. 7 can't fit in the place value, has to regroup. So I get 2, 0, 0. And there, that to me is a pretty quick one to do as well. I get the same answer, 5, 4, base 7, as I did before. But maybe you like that one a little bit better. It's almost like you're just kind of adding little bits, moving them down the number line until you find two numbers you really like. So that's kind of a cool approach there. Oh, let's see how we're doing. What else do we have? Anything else? Trading off. Did I assign any of these? 3, 3 up to number 21. Oh, so none of those. All right. So there you go. That's it for this one. Hope it all works out for you. And I hope you have a great rest of your day. All right. Off you go.